Thank you, Chairman. My name is Jun ISHIMOTO from Institute of Fluid Science, Tohoku University. Today's research topic is the supercomputing approach of flotsam mixed tsunami in narrow region. The motivation of this study is how to mitigate the flotsam mixed tsunami. As you know, the debris or flotsam mixed tsunami, the impact force increases largely increased than the normal tsunami. So we the supercomputational technique to estimate the impact of the power. Not too close. Okay. And we performed two different methods to compute the float tsunami's characteristics. The one method is ALE method. ALE method means arbitrary Lagrangian Eulerian method. And another one is the SPH method. SPH method means smooth particle hydrodynamic method. In approaching the two different methods, we estimate the impact force which acts on the land structures. At the first, the background. In recent study of tsunami simulation conducted by the oceanic scientists, generally deals with a wide region, which across several hundred kilometers, and use zoning equations for analysis using such as shallow water theory. Although the conventional simulation techniques successful predicting tsunami height and inundation area, use of the shallow water theory. But with respect to the impact force exerted on the object structure cannot be accurately predicted. Especially for predicting damage of the land and buildings in relatively small area, such as the industrial plant, is not possible to apply for conventional simulation procedure. The March 11th earthquake is further believed that mixed tsunami with rubble by reading wave and the outflow of the flotsam by backwash greatly increased and destructive power as compared to the normal tsunami. So in the present study, the fully hydrodynamic approach without shallow water approximation is applied to compute the flow characteristics of mixed tsunami accompanying with the flotsam and debris. Furthermore, the mixed tsunami damage prediction to the structure by reading wave and the outflow backwash of the flotsam and the geometric structure placement optimization are performed by supercomputing implementation. In our study, we are focusing on the relatively very limited localized region. This region is assumed the power plants, industrial plants, taking into account the interaction of the structure and the tsunami, fracture behavior, and structural deformation. And we are also developing the simulations method for the flotsam mixed tsunami behavior interface, deformation, and collision to the structures. So in general, the tsunami simulation is generally performed in a wide region, but we are focusing the very localized small region. So the tsunamis and this is first we explain the ALE, FEM of tsunami vehicle drifting behavior. The ALE method, this means the arbitrary Lagrangian Eulerian method for the tsunami simulation, which uses the FEM vehicle model for collision analysis. The tsunami is treated as the Euler element, and vehicles are treated as the FEM model with two FEM model for collision analysis. For a vehicle FM model, the small vehicle is assumed the GEO metro, and the large type vehicle are assumed pickup truck. And this, the formation of the meshing, the 50,000 elements are required for each cases. This is the simulation result of the flotsam mixed tsunami behavior. The tsunami's hydrodynamic impact to the vehicle and the drifting behavior of the vehicle is reasonably simulated. The vehicle is covered with tsunami and is washed with tsunami's inertia effect. Okay. And the second case, the lumbar mixed tsunamis. Lumbar means Utskuram. The mixed tsunami, the hydrodynamic impact to the behavior to the water gate. We assume that tsunami is Euler element, and the water gate is assumed to be the Lagrangian element. And the concrete section is assume the rigid body, and the water gate is assumed to be the elastic plastic body. And the flotsam is treated as the Lagrange element, and the flow velocity and the size of a water gate is set to these parameters. This is the numerical result. The lumbar mixed tsunami's hydrodynamic impact behavior to the water gate. This is a single phase tsunami without flotsam case. And this is a mixed tsunami with lumbar case. The increase of the flexibility and impact stress. This is color contrast shows impact stress towards the water gate by the impact of the lumbar. The mixed tsunami is numerically reproduced. Okay. From these simulations, we computed the effect of flotsam lumbar mixing to tsunami on impact force to the water gate is estimated. This red line shows with mixed tsunami's case, and blue line is the impact force of the single tsunami's case. It is clear that mixed tsunami's impact force very increases in than that of the single phase tsunami. So the impact force, the magnitude of lumbar mixed tsunami increased to as twice than that of single phase tsunami's impact force. Okay. Next simulation, we perform a different approach by the computational results of flotsam mixed tsunami behavior by SPH method. SPH means smooth particle hydrodynamic method. We assume the numerical model like this. The two small tanks rolled up and impacting to the large tank. We constructed the numerical model to investigate the flow characteristics of float sum. Float sum means this small tank, tsunami, a mixed tsunami case. We assumed two assumptions. The float sum obstacle was carried away to the backwash of the first wave of tsunami and was rolled up in the second wave of tsunami. The float sum went up on the shore and collided the land structure. Land structure is assumed to be this large tanks. And the small tank is assumed the rigid body model, and large tank is assumed to be the rigid body or elastic plastic model. Okay, and the fluid material parameter and fluid dynamic parameter is assumed by this. これもパワーがなんかなくなってきたな。なんかないですかね。リプレイス。これは使えないのかな。ダメだな。OK。This plane is the settled by slope, very short slope. Okay. This is the simulation result. The float sum mixed tsunami flow. This is the without float sum case, namely the single phase tsunami case. And this simulation result is the float sum mixed tsunami case. The float sum mixed tsunami flow characteristics and behavior of its interface deformation and collision to the land structures are clearly reproduced by these simulations. Okay. This is a POV rendering result. This is a two columns case, and this case is a float sum impact and passing through the land structures case. Okay. The behavior is clearly and reasonably reproduced by this numerical technique. Okay. This is a different views case. Okay. This is float sum or debris. Okay. And next simulation, we assume the large tank is the elastic plastic body, and to investigate the impact stress profile structure while the float sum mixed tsunami impingement. Okay. When the float sum impact to the structure, the stress suddenly increases. Okay. The maximum impact stress is obtained to 100 megapascal, and corresponding maximum plastic strain is this value. Okay. This color contour means the stress. According to these simulations, we are predicted the impact force of tank to land structure. This black line shows the single-phase tsunami, namely the without flotsam tsunami's case. The impact pressure is not so large by compared to the red line case. Red line case is the flotsam mixed tsunami's case, and we obtained the maximum impact force. The single-phase tsunami is maximum the 3.5 meganewton, but flotsam mixed tsunami is maximum impact force are predicted 42 meganewtons. So the impact force magnitude of flotsam mixed tsunami becomes over 10 times than that of single-phase tsunami's case. From these results, the impact force is controlled by the density of tank and the inertia effect, which acts to inertia effect of tsunamis, which acts on the flotsams. Okay. Conclusions. The two different computational methods are performed, and the tsunami's interface deformation and collision behavior and to the land structure is reasonably reproduced. And impact stress profile land structure, while flotsam mixed tsunami impingement is predicted. As a result, the impact force magnitude of flotsam mixed tsunami becomes over 10 times in maximum than that of single-phase tsunami. Okay, and we appreciate the special gratitude for Tsunami Code Program in cooperation with the Ransomware Corporation and Explosion Research Institute corporations. Thanks.